Okay, trying to find t means that you're going to end up having to do log on both sides because t is your variable that you're solving for, and it's a power. So when you're trying to solve for a variable that's up here in the exponent position, the only way to do it is to do log to both sides so that then you can use that power property and bring that variable down in front. Okay, so first you want to identify what's what. Reading this, an artist creates a sculpture out of salt that weighs 1,000 pounds. Now we know 1,000 pounds is either going to be A or P, but we need to read a little further to see if that's what we're starting out with or if that's what we're ending up with. So it says if the sculpture loses 2.8% of its mass each year due to erosion, alright, so that means we have a decay in 2.8%. If you divide that by 100, you'll get 0.028. And then ask how long, so we're looking for time, how long will it take for the statue to only weigh 500 pounds? So this is our ending amount. So that means A is 500 and that P is 1,000 because we're starting with 1,000 and finding how long will it take for it to go from 1,000 pounds down to half its weight, which is 500 pounds. So plugging these into our formula, that means 500 is equal to 1,000 times 1 minus 0.028 to the t power. Now before you go logging anything, you first have to get your base isolated. So what we're going to do to isolate our base is divide by 1,000 and get rid of that number in front. So that cancels out there. 500 divided by 1,000, that's 1/2 or 0.5. Let's see, to abbreviate that, 1 minus 0.028 is the same thing as 0.972. All I did was do that in my calculator to get that. Alright, so now we have a much easier looking equation, and we have variable as our power. So in order to solve for that, what we first need to do is log both sides, and you guys already know I'm extra fond of natural log. So I'm just going to natural log both sides and not do a thing. And on my next step, now that I have natural log there, I'm allowed to use that property of logs that says this is allowed to come in front. So I'm going to have the natural log of 0.5 is equal to t natural log of 0.972. Now remember, I'm trying to solve for time. So now that I have t down on the levels, all the other stuff, I'm allowed to divide by the natural log of 0.972. And I'm done. T is equal to the natural log of 1/2 divided by the natural log of 0.972, and that is approximately 24.4 years. And since these are word problems, we do want to bother with approximations. Alright, example 8. A house was bought this year for $200,000. Okay, so still we want to read a little further to find out if that's our A or our P. Assuming a rate of appreciation of 2%. So appreciation means growth, so it's going to be positive. 2% divided by 100, that gives us a rate of 0.02. How many years, so again we're looking for time, will it take before it's worth $220,000? So this is our after, this is our before. So our before is our P, so this is 200,000. And this is our after, 220,000. Okay, so A, 220,000 is equal to P, 200,000. times 1 plus r to the t power. So again, our first step is going to be to isolate our base. So we're going to divide both sides by 200,000. That cancels out over here. And on this side, let's see, those zeros cancel. 22 over 20 reduces to 11 over 10. But honestly, it won't matter if you reduce that or not, because we just need to get the value of t. So our next step, now that we have the base isolated here is to log both sides, because we need to get that t out of the power position. Alright, so this is the natural log of 11 over 10. Is equal to the natural log of 1.02 to the t power. And now, because log is there, and only because log is there, I'm allowed to bring that t down in front. So the natural log of 11/10 is equal to t natural log of 1.02. Last step, to solve for t, I divide both sides by this natural log, because I want t by itself. So I'm dividing both sides by the natural log of 1.02. That cancels, and I get that t is equal to, well, it's equal to the natural log of 11/10 over the natural log of 1.02, and that is approximately 4.8 years. Alright, great.